Okay. Hi students. Okay, in this video we shall go through our answers for measurement and experimental techniques worksheet 2. Let's start with MCQ. Okay, looking at question 1, which option is incorrect? So we are looking at some properties as well as their corresponding SI units. So in this case, answer is A. It's pretty straightforward. For temperature, the SI unit is Kelvin, capital K. Mass is kg, time is seconds, and volume is cubic meters. Okay, so answer is A. Question 2, you have a beaker, pipette, measuring cylinder, and a burette. These are common pieces of laboratory apparatus that are used to measure volumes of liquids. They ask you which list of apparatus shows an order of increasing accuracy for measuring a fixed volume of liquid. Okay, so answer here is A. So beaker, measuring cylinder, followed by pipette and burette being the most accurate apparatus. So take note that even though answer here is A, for beaker, most of the time we say that it can only give us a very approximate measurement. In fact, most of the time we only use it for containing chemicals. Okay. Question 3, which row is correct? So looking at the apparatus and its corresponding accuracy. So for electronic balance, depending on what you use, usually it's plus minus 0.01. Some can even go up to 3 dp. Digital stopwatch, 2 dp. Burette is plus minus 0.05. So the only answer that is correct here is mercury thermometer, plus minus 0.5 degrees Celsius. Question 4, which of the following does not have an equal volume as the rest? So this is unit conversion, right? So A, 1 liter, we know it's 1,000 cm cube. That's equals to B. And C, the conversion for 1 dm cube is also 1,000 cm cube. Okay, so the only one that is different from the rest will be 1 cubic meter. So answer is B. Let's carry on with question 5. Which of the following pairs is correct? So we are matching the quantity with the apparatus for accurate measurement. So part A, we're looking at temperature. So temperature, we use a data logger. For mass, we will use electronic balance instead of measuring cylinder. Part C, volumes of gases, we will use gas syringe. And option D, we do not use beaker because beaker is just for approximate measurement. Question 6, the boiling point of liquid X is lower than that of water. A student places a thermometer into boiling liquid X. The diagram represents part of the stem of this thermometer without any numbers. Question asks you, what is the boiling point of liquid X? So from this particular statement, first statement, you will be able to eliminate two options immediately, right? Because you know that the boiling point of liquid X is less than 100 degrees Celsius. So straight away, you will cross out option C and option D. Next, you zoom into the thermometer and you will look at this middle part that I'm highlighting. You notice that that's the halfway mark, right? So if the mercury has passed this mark, it means that it has a reading of 5 degrees Celsius over there. Okay, so since it has already passed that mark and it lands at the 0.5 mark thereafter, this tells us that the only answer can only be 75.5 degrees Celsius. Moving on to question 7. Here you have a stone which was dropped into a measuring cylinder which contains 50 cm cube of water. The resulting volume is shown in the diagram below. Question asks you what is the volume of the stone. Okay, So the initial volume reading is 50 cm cube. So the concept that is being tested in this question is whether you know how to read the meniscus. So in this case, you have a concave meniscus. You should always read at the turning point. So you see that I zoom in a bit bigger. So this division here is 81, 82, 83, and then this is 84. Okay, so your final reading is 84 cm cube from the measuring cylinder minus the initial volume, which was 50 cm cube. That's how you get 34 cm cube. So final answer is A. Moving on to question 8. Here you have an empty crucible which was weighed on an electronic balance. After that, a piece of magnesium ribbon was added to the crucible and it was reweighed. The crucible was then heated strongly so that magnesium changed into magnesium oxide after reacting with oxygen, and the crucible was reweighed. The three readings on the balance are shown in the table below. Question asks you, which of the following statements is true about the experiment? So this is really mostly calculation. So if you look at options A and B, mass of magnesium used, so we will take 15.80 minus 15.68 to get the mass of magnesium. So a little calculation here will tell you that the mass is 0.12, which is none of the answers here. That's why A and B is wrong. Next, looking at C and D together, mass of magnesium oxide formed, we will take 15.88 minus the mass of the crucible, which is 15.68. That should give us the mass of magnesium oxide, which is 0.20. So answer here is C. Let's look at question 9. The diagram below shows two methods of collecting gases. Method 1 is this, and method 2 is this. Which row gives the properties of a gas that can be collected by both methods? Oh, I forgot to play this. Okay, collected by both methods. So looking at the first setup here, you notice that there contains water. So this immediately tells you that the gas has to be insoluble in water, meaning it does not dissolve in water, right? Otherwise, there's no way you can collect the gas using this method. Secondly, looking at method 2, you also know that this gas has, in terms of density, it is less dense than air. So being less dense, it will float upwards. Therefore, you can collect it via upward delivery. Okay, so then you do your tick for A and B, and then B and D. So final answer is B. Insoluble in water, less dense than air. Question 10. Gas X is less dense than air. How can it be collected if it is very soluble in water? Okay, so similar kind of concept from the previous question. So knowing that it is very soluble in water, surely you cannot use downward displacement of water. Next piece of information, they tell you that it is less dense than air. So you can use upward delivery to deliver the gas upward. So therefore answer is C. The other options are incorrect. Let's move on to structured questions. Looking at question 11A, convert 2.5 dm cube to cubic centimeters. So over here, the conversion is 1 dm cube gives you 1,000 cm cube. So therefore, 2.5 dm cube will be 2,500 cm cube. So that is your answer. B, part 1. Give the readings shown in the apparatus below. So part 1 is measuring cylinder. You see a convex meniscus. Again, it doesn't matter whether it's convex or concave. Always just look at the turning point. So each division here in the measuring cylinder is 1 cm cube. So if you locate the turning point, you'll be reading off this point here. So that's 34 cm cube. So note that measuring cylinder gives us up to a decimal place. So it should be 34.0 cm cube. Burette, on the other hand, is a little more special. Notice that in chronological order, it's downwards. Okay, so just be careful of that. So here our concave meniscus, again, locate the turning point. So this is the particular point that we are going to read off. Okay, so 32.1, 32.2, 32.3, 32.4, 32.5, 32.6. So again, in terms of accuracy, it should be to 2dp plus minus 0.05 cm cube. So please leave your answers to as 32.60. Question 12, you are given some apparatus to measure volume. Part A, which apparatus will be suitable to collect 50 cm cube of oxygen gas? So whenever you see the word gas, straight away your answer is gas syringe. Very simple, right? B, add 20.40 cm cube of a liquid to a beaker. That you would use a burette. Okay, again, notice that it's 2dp, so burette. Part C, measure exactly 25.0 cm cube of aqueous alkali. So whenever you see the word exactly and you see such golden numbers, magic numbers, 25.0, 20.0, 15.0, this one always prepared. Finally, part D, measuring approximately 100 cm cube of water, that would be your measuring cylinder. Let's look at question 13a. Give an advantage of using a data logger instead of a liquid in glass thermometer to measure temperature. Okay, so over here, we can write our answer as there's quite a few things that you can address. So first and foremost, data logger definitely has greater accuracy compared to just a mercury thermometer, because in a sense, data logger is like a mini computer, right? So it has it's definitely much more reliable. It can also be used for long periods of time. For instance, if you want to track the temperature changes of a reaction across a period, data logger can be done without too much monitoring by the person conducting the experiment. Thirdly, it is also able to give us less possibility of human error compared to a conventional alcohol or mercury thermometer. Right? So the human error that we are talking about here mainly will be parallax error. Right? So for instance, if you were to use a regular thermometer, it requires the person to read off the reading from the thermometer. So if you are not looking at it directly, perpendicular to the instrument, then you might result in parallax error. Okay. Part B, give a disadvantage of using a data logger instead of your regular thermometer. So again, there are a few answers that you can consider. So the first one would be the higher cost, okay, of your data logger. Second, there is a need for an additional temperature probe or temperature sensor. So compared to a laboratory thermometer where you can get readings just from the thermometer itself, right? So it's an extra component. And final answer here that's suggested for you is that data logger also depends on a power source. So either you need to power it via batteries, or you might need to connect it to a socket that's in the wall. Okay, so these are disadvantages. Part C, temperature on the absolute scale is measured in Kelvin. That is your SI unit. Question asks you what is the temperature of 133 Kelvin in degrees Celsius. So this requires you to do a bit of conversion. So following the formula, the relationship, temperature in degrees Celsius is temperature in Kelvin minus 273. Okay, so the usual way that I remember is temperature in Kelvin equals to temperature in degrees Celsius plus 273. So this is just a shifting over. Okay, so you plug in the values, 133 minus 273, you get negative 140 degrees Celsius. Final question, question 14. A student wanted to collect a sample of a gas. He found that the gas is soluble in water and denser than air. Part A, name a method that the student can use to collect the gas. So over here, the most straightforward answer is downward delivery. So based on the properties that they have given to you. So looking at the first one, right, soluble in water. So knowing that a gas is soluble in water, straight away you can eliminate downward displacement of water, right? So you're left with upward delivery or downward delivery. So to decide that, you will look at the second property, which is density with respect to air. So knowing that this gas is denser than air, it will sink, right? So you have to use this method, downward delivery, so that your gas gets collected at the bottom and then your air is just floating on top. You can also write using a gas syringe because that is of course an answer. So should your answer be this, then in part B you just draw the labeled diagram for your gas syringe. Okay, so take note that here in the question they already mentioned that you need to label your diagram. So if it's downward delivery, label the gas going in, label the gas jar, label the delivery tube. As for the diagram of the gas syringe, you should label the barrel as well as the plunger of the gas syringe. Part C, name another method or apparatus that can be used to collect the gas. Okay, so this is just the reverse of part A lah, right? So the other answer that you did not write. So if let's say previously in the previous part I wrote downward delivery in part A, then part C, another method is just basically the other answer, which is using a gas syringe. Okay, so that concludes our going through of answers for our chapter 2 worksheet 2. See you in class. Bye.